Okay, this is most assuredly notes. So this is going to be able to be used when we hit our first quiz on this, which probably will be next week. I'm not sure we're going to get to it this week. But let me get this out of the way for a moment. Okay, so when we talk about a complex number, we've talked about square roots before, okay? The actual name for that little symbol that's over it's called a radical. So, square root of 49. Well, what? Yes, 7, exactly. So what would happen, though, if I get a negative number underneath there? Well, if I go to punch that in my calculator, so I'm sitting here going, all right, so Hardy wants me to figure out what the square root of -1 is. And I go to hit that and I hit enter, and it says, ooh, error, non-real answer. So does that mean we just get to skip it? Maybe before, not anymore though. Because what we're going to do is we're going to find something that allows us to actually solve this. So stick with me on this. When you find a square root of a negative number, you've got to kind of get a little bit of a mental picture about something here. And it's called the number I, not the letter I, okay? Not like I, like an eyeball, okay? An I, but you can kind of use the eyeball reference to help you remember. So for instance, if I want to find out what the square root of -5 or some other number is, what I always tell you is you need to pull an eye out. So if you literally need to get this picture in your head that your eyeball is here and you're literally pulling it out, do that, okay? So once I pull that eye out, it becomes positive, okay? Whatever's underneath there. So I, in actuality, this value is the square root of -1. But if I were to square that, a squared and a square root would cancel out. And so I squared itself is the actual number, okay? But we're not going to do as much with I squared as we do with I. So you're like, okay, this might be all right. We'll kind of see. So when we actually start working some of these, there's a couple of ways you can do it. If you've got a pretty good grip on your perfect squares, okay, this isn't too bad of a thing to do. Whenever I see that negative, I'm going to pull an I out right away, and I'm just going to leave whatever's underneath under the radical. So just kind of to go back, so I know we already set it up above, what's the square root of 49? 7. So this answer is just 7I.
You have to write the I.
Have to have the I. Because the I is what takes care of the negative part of it.
So it's kind of like X equals. So all you have to do is put two I.
Because it makes it positive?
Yes. And right.
Are those always negative?
Yeah, the only time I'm going to use I is if I see a negative number under here.
So,
otherwise you just ignore it?
Yes. So like for number 2, I pull an I out. What's the square root of 4? 2. So I have 2I. However, is it going to come out as a nice, clean square root every time? No. Well, what do I do then? So like here, I pull my I out, and I go to do the square root of 7, and I'm like, I don't think that's a perfect square, and I go to do something with it, and I can't do anything else, then that one's just done. And it's kind of weird, but that's all I can do. I can't break down the 7 anymore, and I don't want the big long decimal. Okay, that really isn't going to do a whole lot for us. So as we do these, we kind of go, okay, I'm going to treat I sort of like I would a variable, okay, whenever I'm doing something with it. So if I'm squaring 5I, okay, it means I have 2 of these. Notice there's no square root, though. There's no radical, okay? So let's just do this a little piece at a time. What's -5 times -5? 25, positive. And I times I is I squared. Okay, not 2I, but I squared. And here's where this little bit of info comes in handy. Whenever I get something that has I squared in it, I'm going to substitute -1 in where the I squared is, because that's actually its value. And so in this case, I can actually get to an answer. No more I. Okay?
You just had
Right, but now it's negative 25 because the I squared becomes a negative on that. So that's kind of what we're up to. Thank you. To see how those go. So, as you're doing these, what you tend to start finding out, it's the same thing on 5. I have 2, 3 i's. Multiply the numbers together, gentlemen. Okay. Which would be 9i squared, because... Huh?
Is that all you really gotta do is just like square the number?
For now, we're building. But, that's right. Because the I squared, we know we can substitute this negative 1 in for it. So, right, it's going to be negative 9.
So if it don't got a little, never mind.
A square root, like a radical?
No, like, what I gotta do is like, multiply square root. Not square root,
The square, perfect squares of those?
never mind. I know what I'm trying to say, I just know how to say it.
When you figure it out, let me know.
You're putting like the negative 1 in there because the I and the squared.
Right, the I squared actually equals negative 1. So that's why, right, I'm plugging it in 4i squared on that, okay? The only other thing that can kind of get thrown in is a twist here on us. You're like, well, now what's going on here? Well, that 7's just normal. I'm going to leave it alone. What happens? What should I do again when I see a negative in the square root? Pull an I out. So, once I pull that I out, now it becomes positive. So what's the square root of 25? 5. Now here's where life gets weird. Okay, 5i is just this. Square root of 25 is 5 with an I. Treat this like a variable. I can't do 7 plus 5 here and call this 12i. Just like if this were 7 plus 5x, I wouldn't be able to put them together. These are different terms. That's as far as I'm going to be able to go on this one. So you kind of start to see how this breakdown comes. Now, there's going to be some values sometimes that aren't going to be perfect squares, but I still can simplify them. So here's what I want you to do for the moment. We're going to flip this over. Now, for this part, you're going to like this. Okay, wipe that for right now. I'm not going to get into a lot more complexity with this. As long as you understand that I squared is negative 1, and if I want to get the negative out, I pull an I out, I'm a happy camper.
I'm actually past this.
Okay? Now, simplify each irrational radical completely. Here's where I'm going to offer up some more help. And I'm going to pause. So it says simplify each irrational radical completely. In other words, it doesn't come out just nice and pretty for us. Because if I go to the calculator, I'm like, I'm not sure how this is. So let's see here. So, okay, let's clear that out. So let's say I went to the calculator and I'm like, okay, I want the square root. To get the square root, let me clear this back out, is second and x squared. Okay, you see the little square root sign right above it. If I go through that and just hit 27, well, I get this decimal. And again, decimals do not work for us on these. Never a need for us to do the decimals. So here's what I have to do. These numbers that are up here above are all what are called perfect squares. So for instance, if I took the square root of each one of these numbers, square root of 4 is 2. The square root of 9 is 3. And the ones that are listed here are the basic ones that if you can have a feel for them, like if you see the square root of 49, you know that's 7, okay? You've got a feel for this. If you can get a feel for these up to at least 10, now on here I'm going to have them for you up to 15, and they're also on this chart that I handed out to you, which we'll get to in a minute.
And we did this at the beginning of the year.
It's true, we did do some of this at the beginning of the year. So now what we're going to do is we're going to use these to help us. And sometimes for some of you, we may just go straight to the calculator and start helping us break these down a bit. So here's how this works. We need to find two numbers that multiply to equal 27. Now here's the catch. One of the two numbers has to be in this list that's already on your paper, okay? Not the numbers below it, but the ones that were originally here. So when I go to break this up, okay, I'm going to have two square roots I work with. Okay, so 9 and 3 is 27, and 9's in my list. So I'm going to use a different color here with my 9. Okay, so 9 times 3 is 27. One of those numbers, again, always has got to be from this list. So then I say, okay, the square root of 9 is 3. The square root of 3 is not in the list. It's not fancy. It's not perfect. It's got to stay in radical jail. If you're perfect, you get out of radical jail. New identity. If you're not perfect, you have to stay. This is the answer, okay? This is my answer at the end. And if I'm not sure, it's like, well, I'm not sure if this is the right answer or not. Here's the other thing I could do. I could say, okay, 3 times, and again, it's second, next 3 times the square root of 3. Exact same decimal, okay? So I've just simplified this, and what this is going to allow us to do is it's going to allow us to solve equations and combine like terms later. We wouldn't be able to normally.
So do you like divide that number by that number?
You could. You could. If you were looking at that and you were like, I have no idea what times what equals 27, okay? I'm not real good with my multiplication. Here's what you can do. You could just start at your list at the beginning, and you could say, okay, I'm just going to try dividing some of these in. Well, that's a good idea. Oops, that one didn't work. Well, let me try the next one. 27 divided by 9. Ooh, 3. So I could do 9 and 3 like I did here. Sometimes it'll be a little bit of guess and check, but you'll be surprised. The more often you do this and start playing with it, the more often it's going to be like after a while you're just going to snap it off. You're going to be like, oh, 27, 9 times 3. And have it, okay? But here's one other thing I'm going to make note of here. When you're trying to find a number that goes in, you want to find the biggest one that goes in. Because if you don't find the biggest one, you're going to be like half right. So let me explain what I mean on that one. So let's say we're doing 48. I'm going to split this in half here just to let you see the advantage of finding the bigger one. All right. Can anybody tell me a couple of numbers that multiply to 48? But remember, 16 and 3 would be an option. And there's one other one.
Is that the biggest one?
16, I think, is going to be the biggest one here. Okay, 4 and something. 4 and 12 would be the other one. Now, some of you would say, okay, 4 is in the list, and 4 times 12 is 48. I'm doing this right. Others of you would say, well, wait a minute. 16 is in the list. 16 times 3 is 48. What's the deal? Here's how this works. With this being the bigger perfect square, okay, the square root of 16 is 4. So it's 4 square root of 3. Okay, I'm done. Because the square root of 16 is 4.
You just put that in the front.
Right.
The bigger number.
Yep, the perfect one, the one that gets out of here and turns into a different number, always goes in front. The one that doesn't change, the one that's not in my list, always is going to go second. But you're like, well, what if I did 4 and 12? Why am I not getting the same thing? Square root of 4 is 2. You're like, okay, 2 square root of 12. Well, that's not the same thing. Here's why you want the biggest one. I can break the 12 down again. Because you're like, ooh, that's right, because 4 goes into 12. Wait a minute. If 4 goes into 12, that would be, and I'm forgetting about this for right now, The square root of 4 is 2, and I can't break down the 3. Oh, but the 2's out here still. 2 times 2 is 4, and I get back to it. It's a bunch of extra work that we really don't want. We really don't want to have to deal with that. So just keep dividing in these numbers and try to find the biggest one you can humanly think of that'll go in. But again, if you're not sure, now I'd hope with 125 you'd have a little bit of a hint there. But yeah, 25. But if you're not sure, try something. You'd be like, oh, I don't know. I wonder if 49 works. Let's see. Oops. Definitely don't want to do that. Okay, that's a decimal. Okay, it didn't work. Oh, let's try 36. Because Hardy says try the bigger ones. So then you finally get here and you're like, okay, divide by 25. Oh, 5. Okay. So I've got the square root of 5. And I have the square root of 25. Because again, nope. So now I go, okay, so the square root of 25 is 5. Square root of 5, what's that 2 doing out in front? Whatever I get when I break this down, I'm going to times by 2. 2 times 5 would be 10. Square root of 5. So my first job always is to break down what's underneath the square root.
So you don't do the 2 and the other 5?
Nope, just to the ones that are out of radical jail. We are not mixing in and out of jail together.
You can't divide anything that's in the...
Right, because once we simplify this, that's going to be as simple as it gets, as long as I get the biggest one out of there. Good question. So one more. Is that a negative 5? I believe it is. So again, here's my job. 63 needs to break down. So try some numbers out, the black ones from up here in the list, until you find one that goes into 63. When somebody finds one, let me know. We'll break this down. Okay, 9 does. And when I divide 9 in, I get 7 out. So 9 times 7 is 63, but 9's in the list. So I'm like, okay, square root of 9 is 3. Perfect behavior, gets out of radical jail. 7, still acting irrationally, has to stay. But now, once I break that down, now that negative 5 that was hanging out there, I just multiply these together. Okay, just the ones that aren't underneath the radical, though. And I'm done. Okay. So the only thing that's left out of all of this radical stuff, okay, we've broken them down, we've pulled out an I. What else can you possibly throw at us that could cause an issue here? One more small thing. Get this back out of the way. What if we start throwing variables in? Now what's going to happen? Here's one thing I want you to be aware of. Whenever I've got a square root, there's this little thing on the outside, okay, which is your actual root. For our purposes, it's going to be 2 every time, okay? And that's important because when we go to start breaking this down, okay, what's the square root of 4? 2. Okay, so we don't have to do any fancy stuff with this one. But here's how I figure out the variable part. We're just dividing. Right, because I take whatever my exponent is on my variable, and I just divide it by 2.
The next one will be 3x, 3x squared.
Yep. So 2 divided by 2 is a, or a to the 1, and I'm done.
Wait, how'd you get 1?
Exponent divided by the little number, so 2 divided by 2 is 1. On this next one, okay, the square root of 9 is 3. We've got that up above here. Let me pull that down so we can see it. And what's 4 divided by 2? 2. 3x to the second power. Now, will they always come out nice like that? No. Sometimes, Okay, like here's 300. Now 300's not in my list. So I got to break down the 300 first. Now, there's a number up there that should be pretty obvious. 100. So right now I'm just breaking down the number. No, the only time I'm doing the divided by 2 is with my variable. When I'm doing this part, I'm still doing like exactly like what I did up above. That's a good question. Yeah, this little 2 here only deals with my variable term. I'm still breaking down square roots here. So square root of 100 is 10. Square root of 3, and then I do the variable part. So what's 4 divided by 2? 2. So my a to the second goes outside, okay, with my 10. So you're like, okay, so that's just straight division. That might not work too bad. This might be all right. But then, of course, well, we always have to throw a little something in. So let's move down to 35. 24, not in my list, which means it breaks down. 2 numbers that multiply to 24, one of them has to be from the list. Okay, 4 is in the list. And 4 times 6 is 24. So we're like, okay, perfect, outer radical jail, so that's 2. 6 is not on the list. It is not perfect. I'm going to leave a little bit of space here this time, because I still got to deal with my variables.
How about switch to 3?
Nope, if this isn't perfect, I know what you're thinking. You're kind of thinking here with our little 2. The little 2 only works with our variable
Why
terms.
can't you just turn the 6 into a 3?
Because 3 times 3 is 9.
Ah, that's one reason. Let me show you one other reason why we can't do that. Okay, so if I do the square root of 24, just so I can kind of see how this all works. Okay, so now if I took this and I broke this down, now are you thinking it just becomes plain old 3? Or like the square root of 3?
Like the square root of 3. Like that's
Okay.
just turning to-
So if that would turn into...
Since you're breaking down the 4 into a 2, I thought you did the same thing with the 6.
Okay, and I can understand that. So if I tried looking at it and I thought, okay, maybe this is 2 square root of 3. Well, my decimal's showing up a little bit different. So here's how this works. The reason this gets to break down, the only reason it gets to break down is because it's in my list right here. And the 6 is not in my list up here, so it doesn't get to break down. But it's only the original numbers up here, not what they turn into. Okay, yep. Good, I'm glad you're asking the questions. This is good, because I want to make sure this works well. So then I get to the variables, and I say, okay, what's 4 divided by 2? 2. So I have a to the second. Here's where life gets interesting. You're like, hey, wait a minute. 3? Ugh. We've got to think about this a little like we would long division. So if I were back doing some grade school long division here. Oops, and I'm stuck under the calculator. Okay, there we go. How many full times does 2 go into 3? Okay, once. Okay, that's what gets to come outside. So I'm like, okay, so 2 times 1. What's my remainder going to be? My remainder is 1. The one that's left over has to stay inside. And this is going to seem really weird to some of you, because you're going to look at this, you're going to go, wait a minute. 1 and 1 isn't 3. That doesn't make sense. But here's what you've got to remember. When we're doing that, okay, when I'm doing the square root of b to the third, when I'm just looking at it that way, here's what I'm actually doing. I'm saying, okay, b to the third is actually 2 and 1, because I'd add my exponents. The square root of b squared, well, 2 divided by 2 is 1. That's perfect. That goes in nice. Well, 2 doesn't go into 1. Well, that's why that one has to stay underneath. Okay? So these aren't going to add up at the end. Just like when we did this one.
So you're putting the B's, like the 1 with the 2 and the 2?
Yeah. However many full times it goes in, whatever this number is what goes on the outside. Whatever I have left over at the end is what's going to stay in.
But it's not a 1, it's a 3.
Right, but here's how you've got to remember it. Let's do it on this one, just so we can kind of see another one. I'm not even going to worry about the 60. Let's just look at the y to the 7th. Here's how this works. So I've got 7, okay, divided by 2. 2 goes into 7 3 times. So I'd get y to the 3rd out here. It's not underneath the radical anymore. So let's see, 2 times 3 is 6, which means I have a remainder of 1. That 1 that's left over has to stay underneath. And it's strange. It goes against what your natural thinking process would be on these. But whenever you're doing them, okay, let's just do exponents here. So I'm like, okay, 3 divided by 2 is 1. So I'd have 1m here, or m to the 1st if I wanted to. 2 times 1, I've got a remainder of 1. Okay. The remainder stays underneath, if I have one. When I look at p, 2 divided by 2 is 1, but I don't have any left over, okay? Because if I do 2 divided by 2, okay, I have no remainder. When I get to r, then I do it one more time. So 5 divided by 2 goes in twice. So that's what gets out. And anything I have left is going to be underneath. So it's just kind of a general base rule that we're trying to follow. And all I've done on the help sheet that I handed out a little bit later is gave you a chart where some of these combinations are. So like for instance, if you look at 24 and you don't know that it's 4 and 6, here's what I've tried to do with this sheet that I handed you. I can find the number that's underneath the radical in my chart, and then if I follow it to the edges, oh, it's 6 and 4. So basically, the numbers on the outside, and this is one of the reasons I'd put up there, grab a colored pencil. These guys are the numbers that multiply to get the numbers in the middle. So any number you find, just go to the edges. So this is 6 times 4, and then I can break it down. Or like if I was doing, let me find another one here. If I was doing, okay, let's say I was doing this 128, and I have no clue what comes up to 128. So then I brought this chart back up, and I'm like, all right, let's see. Ooh, there's 128. What is it? It's 8 times 16. And then I can break it down. This chart's to help you figure out what two numbers do I multiply to get the number underneath. It's just kind of a cheat sheet in that way. So what I'm having you do with this is when I put this over here, and I'll move the radical help sheet out of the way. When we're doing these on the actual work, here's how I would think about these. Okay, and this is the homework. So like if I have 52, I'm like, well, 52, let's see. Some of you, if you don't want to have your notes out with you all the time, may at least want to write down some of the perfect squares on the top of your sheet, maybe up to 10, just to know what's up here. because then you can start just trying to divide them in. And so maybe you try 36 and that doesn't work. You try 16, that doesn't work. And you're like, maybe none of these work. You try 9. Ooh, you get to 4. And you're like, okay. When I tried 52 divided by 4,
13.
yep.
I know what's the biggest one. That goes in there.
Normally what I'll do is I'll start further along in the list and start dividing them in and start working my way backwards. That's the easiest way to make sure you get the biggest one. Because if you start from this end, you may get one right away, but then you find out later it's not the biggest one. So I get here and I'm like, okay, square root of 4 is 2. And even if I wanted to, I guess I could write the square roots right below them. As long as I remember, it's the red numbers are the ones that I'm trying to get to be one of these two. So square root of 4 is 2. 13's not in the list. It doesn't get to come out. And I can always go to the chart. Not every number is going to be on the chart. I mean, this chart had to be huge, but a lot of the numbers are going to be on there. So then I get a little further, and I go, well, let's see. Ooh, number 7. Oh, there's an I. So when I'm looking at these, now I did something kind of strange on those. Help me out on something with this. Take the I's, scratch them out, because I did something weird. Very weird, actually. Mathematically, it would have been more difficult to do this than I want it to be. So we're going to scratch the I's on those. We're just going to stick to variables and numbers here. So one more time here with the variables. So let's say like we're doing, I don't know, let's start with 10. Knock some of these out. We're going to ignore the 7 for right now. So 63. I need one number from the list that goes into 63. Okay, 9 goes in. And if I do 63 divided by 9, I get 7. Okay, so, I'm going to write my 3 down, because that's the square root of 9. My 7 has to stay underneath the radical. Okay, it's not in my list. It's not perfect. Notice I left a little bit of space, because there's a variable this time. And that little 2 is always hanging out here. So what's 2 divided by 2? 1. So that x, or x to the first, comes out. I don't have a remainder. So that part's done, but this is my breakdown of the radical, but the 7's still here. Just what's outside the radical gets times by the 7. So 7 times 3 would be 21x. And then that number under the radical stays there. Only stuff that's not in radical jail gets to get together. We're not intermixing us free from those that are in jail. Not doing it. Let's see. I want to find another one. Ooh, right below it. Right below it. Number 13. All right, 60. Number in the list that goes into 60. 4. And if not, again, just play with the calculator. Divide them in until you get one that goes in nice. 4 and who? Close. 4 and 15. Now again, the 4 is in the list. It gets to change. 15 is not in the list. It does not get to change. And they're like, Hardy, you're making space again. Yes, because I see there's variables. Because here's where we do the long division part. And I got a way to make this click better. Okay. Take my exponent. Divide by 2. How many whole times 2 go into 5? 2. So I get x squared. 2 times 2 is 4. I have a remainder of 1. The 1's got to stay inside. Yeah, is if you can work through this mentally and you're just like, this goes here, I'm fine with that. But I just want to let you see how this works. So then with my y to the 7th, it's the same thing. However many times 2 goes into 7, 3, is the exponent that comes outside. 2 times 3 is 6. Whatever my remainder is, stays under. So even if maybe the variables are bugging you right now, for now then, just break down the numbers, okay? But do something on this to start reinforcing, because we're going to spend tomorrow doing something similar to this again, and then we're going to start adding them together, multiplying them together, and doing the simplifying. So it's one of those things we've got to fight through, okay? So